Hello, everybody. Thanks for staying here. It's actually a bit late now. I can imagine your brains are a bit fried as well. So we're going to try to make it fun as well. So it's not just like talking a lot. Also, we're going to have some nice memes, so laugh a little bit. So again, thank you very much. Especially thank you to the MISP team to accept our talk. We're really happy to be here. We have been following this project for quite some time, so we are really happy to be part of it now. So what are we going to talk? We're going to talk about our way of using MISP, that is threat intelligence, contextualized, knowledge base. But let's present ourselves. So I'm Leandro, he's Jeroen. We both have a similar background. We did the same master's degree. Now we're both working for KPN Security as security researchers. That's in the Netherlands. But after school, we took slightly different paths. I went more for the endpoint analysis and antivirus. He went more for the SOC and network analysis. So we were working together. It's not working anymore. There you go. So one day, when he was still working for the SOC and I was working for the security research team, this is broken, so cancel this. I'm going to stay here so I can. So I was working for a security research team, and we were like, how can we help each other? How can I help the SOC to have better incidents or better alerts? Because they were like, oh yes, nice, something is wrong, but what's wrong? And how that connects, something like he mentioned before, like something is bad, an IP. Yeah, but IP related to what threat? Is this connected to like a malware? Is it connected to like a network attack? So what's going on? So we're like, research some, and MISP is a really nice project. It was like a couple of years ago. We're like, yeah, let's give a try. And we start looking at the data that MISP consume, especially the free data. And we're like, oh, yeah, this has some potential. So we thought back in that time we were working with Alienvault, and Alienvault has the OTX network. And we were like, okay, we can push some of our events towards the OTX network. And like that, we can share our intelligence towards our customers, but it was not enough. At the end of the day, we were just sharing some indication of compromise that we were consuming from really nice sources, but we didn't know if they were true or we couldn't verify them. We need to add some more layers into that to make something useful with it. So one day we sit together in a nice room and we're like, okay, let's plan something. We need a more complex framework of multiple pieces working together to verify the data, extract more data, have our own threat intelligence, because just consuming open source one is not good enough. So we start drawing things, and we have some flows, and we have some, what are we going to do there, how are we going to share it, and we went crazy with it until our manager said yeah, this is nice, but it's getting too complicated. How can I defend this with the management board? So we try to simplify it, and we remove some of the lines, and we have a little bit less complex. But it was still not enough, especially for a presentation. Yeah, it looks like too much, done by hand. So we have a nicer, schema now. And this is our platform, or this is what we want to, because we are still working with it. This is a work in progress project, sorry. And yes, the idea of today for us is to explain how we came here, what we have, what we plan to have, and yes, hoping that more people here might use these ideas, implement in their customers or their companies. So let's start with the first component in the input. Of course, it's open source intelligence. And it's not just the open source intelligence that we have for free in MISP, which is great, and it has really nice sources, like the Circle event. We really like that. We also try to have our own, scraper. So we have the Cape Sandbox scraper. We try to extract an indication of compromise from known malware families. And we also look at some things of the OTX, and we push it inside of our MISP so we can analyze that. And then sometimes we repush it back to the OTX, but with some of our own enrichments. Then we also have some Circle, of course, and Twitter, because people are really nice and they share a lot. Then we go to our second big input source, and this is certificate transparency. And I don't know if you are aware of this project, but basically, I'm going to try to explain quickly. It's an initiative done by Google to try to patch the certificate authority SSL TLS structure, because what happened a couple of years ago with DigiNotar really changed many people's mind. Like, we cannot just trust the system. We need to monitor the system. We need to be like, we need to be some auditing there, like some analysis. So what happened now is that Google says, like, what if we have like a repository where all the certificates that are being issued in the world are also pushed into this repository, so anybody can just look at them and spot some strange things, like, hey, why is DigiNotar issuing certificates for Google? That's not the case, that they shouldn't be doing. So the idea is that now we have another layer that is public, accessible for everybody, that they can review the data and do some proper auditing. But for us, why is this interesting for us? Basically, we look at this project as a database of certificates, and we can extract the common name. So for us, it's a nice way to get access to domain names. And we use this to extract the data from it. We enrich it with some of our own ideas. We push into an Elasticsearch, and then we create some alarms. We create some analysis. We hand read it. So here we have some examples. Might not be easy to read, but basically we have some Punicode analysis. We do some entropy analysis on top of the domain names. And we also look at, like, if Twitter is supposed to be issued by this particular authority, why is another like rogue kind of certificate? So we use this to hunt for phishing sites or sometimes malicious in general. Here we have one nice example of like a scheme they're trying to do here. Like, you see, get verified Twitter, but if you pay a lot of attention, you see that there's a small thing on top of the I, like that's not supposed to be there. And if you're not really paying attention, you're like, oh, it's completely shit. But trust me, it's not. I did trigger an incident in my company because of that. Then we have this one, and this has another trick. If you pay attention here, they append a subdomain on top of the domain. So people with a smartphone, or they're not really paying attention, say, hey, that's my bank, that's enough. But they don't look at the entire URL. They simply just look at the first part. Especially useful when you have a small phone screen, because you're like, you see just the first part, then the rest is like, it's gone. You don't pay attention to that. And Safari, for example, does this. Google tried to improve that, and they show the last part. So it's easier to spot. But basically, we use this system to extract this sort of intelligence. We see some malicious domain, and we dig into it, and we try to extract a bit more. But these are projects that we chose to have because we were like, these are the things we want for our platform. But sometimes, like things go different sides, and like company has some weird requests, and that was the case with the following. One day we were working with our previous project, doing some hunting, and somebody came from marketing and said, hey, it would be nice to have a cyber attack map, like something that is showing a really 80-inch screen, and we can be like super proud. Our SOC is blocking threats and hackers. And we're like, so basically you want a pew-pew map. And like, you want a Korea thing is, you're like, is this what you really want? And you're like, sure, that's exactly what we want. It's great. It's like, we put in like a brick screen, actually put two screens with the same data. Like, okay, we're like, not really happy about it, but if that's what you want, we can do it. But we have a trick. We use real data. And that was like, for us, was a nice excuse to have our honeypot network, because up until now, we were like, no, who needs that? That's a lot of resources. We don't really need that. And we're like, okay, but now you want a pew-pew map, so we can make a pew-pew map, but also use the backend of the data. So now we deploy across the world, like we have like 90 different honeypots distributed in different like vendors. And that gives us a lot of interesting data because we can see like what has been massively attacked. So basically we do the same trick. We extract the data, push into an ELK, enrich it with ideas we have, and we also have some automatic alerting. And some of the things we can see because of this, like some of like the V-bulletin, now we can see like, oh, this has been massively exploited, and we have real data, real proof that this is happening. It's not, we are not relying on a third party or a vendor says, oh, like, yeah, this is a thing. Same with this thing, PHP vulnerability. And the interesting part of this one is that it's not just the exploitation. We also know they are hosting the second stage somewhere. And what if we get access to that second stage? Then we can understand a bit more what this threat is about. So now we have a lot of data from different sources. Some are more raw than others, but at least we have a big input of resources. And now Jeroen is going to explain what we do with some of these resources.
Yeah, so back then I was still working in SOC and still working on getting the threat intel into the systems of the customers and just resolving all kinds of incidents. And then, Leo kind of shows up with his system and all this new data. And that gives us like a problem. We want to process it, but manually it takes a lot of time to verify and get the context there. So that was not really working for us. So actually, we wanted to do more, and we needed some automation there to get it working. And we set some points first. Okay, what do we need? Like, first of all, we want something that's adjustable for us, like modular, so everybody can work on it, and we're not in each other's ways. And preferably Python-based, because most of us know how to program in Python. So we have set some goals there. So actually, we ended up with the stock framework, the Punch Cyber company, and it gave us what we kind of needed: a Python-based framework, which automatically processes like payloads or other data, and it gives us like a Yara-based flow control, which is really important for us, because then we can keep on using some open standards and use the stuff that the community already produces. So that kind of ends up in this kind of flow diagram. We start with an input, we have a filtering mechanism, then we have a dispatcher, the Yara-based one, and based on what the dispatcher sees, we get it sent to workers, and we keep repeating the circle until it's done. We archive towards elk, but it can also be like to disk or whatever. And just to show you a bit better, I'm going to use some examples. So let's say you have like from a base bin, you find some base 64 string. Nobody now knows, okay, what is this? So this ends up in the system. And then the filter, you can see like new hash, it verifies the hash. That's this most simple filtering mechanism. Okay, new hash, I don't know this one yet. So let's keep on progressing. The dispatcher sees, oh, it's base 64, and it decodes it. So in this case, you see it's a PowerShell who downloads something from Empire, the GitHub from Empire, to do some malicious script. Then we end up, and actually that payload is sent again to like the filter, and it's dispatched again, and this time it's like a PowerShell script, and this time it sends it to our Cape sandbox to process this payload. And we keep references because it can, based on the ID of the previous one, we keep referencing the way back. So you can always see, okay, this payload originated from this other payload, and that came from like a paste bin or some other source. And actually then, because of the sandbox executed, you get to part that you can see, oh wait, there's a connection to GitHub. This PowerShell script is also downloading something which adds extra context. You can then add maybe some maliciousness to say, oh, maybe it's worth investigating it more. So actually, we now went from like monkey work analysts, which is not really nice for anybody. We went to like a way more like modern like car washing system, which we're really happy with. And to show a bit like a more real life example, stuff we have implemented lately is based on REVL. So they post samples on Pastebin, so we can check from there. We can find the payload, identify them. We can extract the DLL from there. From there we can new round. We can extract the config. We push that to our elk, which results in the end in we can show we get some nice data about what's going on by just looking at that data. So these are whitelisted extensions, whitelisted files or directories. So these will not be encrypted by the REVL ransomware. And you can see, and there are quite some different files in there. And if you take a look, these are like most killed processes. So before the encryption starts, it kills some processes. And there, like, well, in the middle, you have like the backup server, which makes quite some sense in a ransomware. kill the backup server first, the backup process first, and then start encrypting, there's a more chance that you get like your ransomware or your ransom in the end. And it's also quite nice. We can follow some of the campaigns because there are IDs in the config file, so you can identify groups and campaigns of those groups. So who's more active, who's doing different kind of attacks or different type of companies, maybe even. That's more or less like our filtering system. And from there, we try to get the output in MISP, because else we wouldn't be here. Well, and for MISP, it's for us, it's a database, which is really useful for us. But the important part is like try to glue everything around it. So all of the data that Leo has, it's from an elk. We try to extract from the elk using PyMISP, get that data out there and feed it to MISP. We have something like a verifier, which actually was explained mostly already earlier in the presentation. That's to, for new data, query customer data, find, is it already out there? Is it, like, do some retro hunts, or at least say, okay, this IP, for example, we never see it in our customer data. It's fairly safe to push it to the feed, because at least it won't give false positives. It's like no security data at all, but at least gives you, will not cause, most likely not cause false positives. And we do some, with content creation, we try to stick towards like some like usual standards, Stick, Sigma, Suricata, Jara, just to make it like, again, more common and easy to distribute later. Although this part is something we are now really working on with other departments in the company to get this really working. So that gives us most of the picture. Actually, with the output, the above picture is for the feeds. We kind of discussed it already, and it's not a huge part now. And then we end up with like reports, which should be orange, because that's like tactical reports. We're not there yet. That's something we want to work on. That's like future work for us to really start producing reports and tell about like what are the trends. That's more management like report. And we really want to work on more Red Hat information in this system. We work really closely together with pen testers. We're in the same department, same floor. So we really want them to start adding also to the system with their knowledge, and probably use more or less the attack framework for that. But, to have their knowledge base also somehow get it into MISP, or at least start combining all the information. So that's really what we want to add. So as like a wrap up for us, more or less like it's been going on for a year now. We're truly trying to build this. So for us, it really gave us like a central database and a place to put our threat intel. We got like a way better overview of all the information and how things can work together than before. The SOC analysts can get better context, because it's not just an alarm and an IP, and they need to Google why did IP is hit and hopefully find something. They can just go to MISP and find why is it there. So they are way more happier, and our roadmap is like lots of stuff that's already been discussed here. It's more on like sightings, and the decaying is really interesting also for us, and get even more insight in the data we already have. Sometimes you're just flooded with the information and you don't know what to do anymore. So actually, that's kind of it. It's like our platform.
Sorry if you said, and I was a poor listener, but was it mainly just the two of you, or about how many? Yeah, really? So how did you manage to keep management off your back long enough to do this work? So you have some kind of like internal skunkworks model that
partly it's also in exposure. We have done actually there's like one extra FTE, it's a combination of two persons who's also working on this with some exposure, which helps. We have it, like marketing helps us. And we try to make our way in that, like find alliances within the company who also want to do this and want to help us out, and thereby get the funds and thereby try to convince upper management to let us play around, more or less.
We are now seeing that part. Very questions. At the beginning it was rocky, but now we see there is nice added value, and they see like, oh, we can go to conference and we can show our work and we can like share with other different departments. So that is standard.
A lightning talk on hacking your management would be pretty cool.
Great idea. We are going to plan something like that. I think our boss is great at that. So we're going to propose that, and I think it's going to have a lot of audience there. Any other question? Okay, then thank you very much again, and yeah.